Hi, this is Sonia Doucette. In this video, I'll show you how to use a calculated cell potential value to predict whether a certain redox reaction will occur. I have two problems to illustrate this idea. In the first problem, you're asked to calculate the cell potential to predict whether nickel will reduce aluminum 3+ under standard state conditions. So you're told here, you're asked whether aluminum will be reduced. And you know that you gain electrons when a reduction occurs. So in this case, you'll have aluminum 3+ in aqueous form gaining 3 electrons to become aluminum solid. And if aluminum is reduced, that means that the nickel solid has to be oxidized. So you're losing electrons during an oxidation. You have your nickel solid, and because you're losing electrons, the electrons will be part of the products. So when electrons are lost, you're left with a nickel cation plus 2 electrons, and that cation is in aqueous form. So what you can do with these two half reactions is you can look up the standard reduction potentials for each of them in a table of standard reduction potentials. So when you look up the standard reduction potential for the reduction of aluminum, you get a value of negative 1.66 volts. For the value for the oxidation of nickel, now when you look up this value in a table of standard reduction potentials, you don't find the reaction shown here exactly for the oxidation of nickel. What you do find is this reaction. You find nickel 2+ in aqueous form plus 2 electrons yielding the nickel solid. And this is just because, due to convention for tables of standard reduction potentials, all reactions are written as reductions. So the value for the standard reduction potential for the reduction of nickel that you'd find in a table of standard reduction potentials is negative 0.26 volts. So you could find this in a table. But that's not exactly what you want. You want the reverse of that reaction. You don't want the reduction of nickel, you want the oxidation of nickel, what you're actually being asked about in this problem. So in order to get an E0 value for that, or a standard reduction potential value for that one, all you do is flip the reaction that you find in a table of standard reduction potentials the other way around. And when you flip that around, you take the negative of the standard reduction potential value. So you have the negative of a negative 0.26, which gives you a positive 0.26 as the value for the oxidation of nickel. So now you have those two values. And in order to calculate the cell potential, which is the sum of the two separate standard reduction potentials, you will get an E0 value, and these should technically be E0 reduction and E0 oxidation because they're not the full E0 cell potential values, they're only for the half reactions. But when you add those two together, you get a value of negative 1.4 volts. So that is actually the cell potential value that you were asked to calculate. And the general rule with cell potentials is that when you have a negative value, the reaction is non-spontaneous. And when the reaction is non-spontaneous, then it will not occur under standard state conditions. So here you have a negative value. So the answer to the question you're asked here is no. This redox reaction will not occur under standard state conditions because the E0 cell potential value is negative, and that means the reaction is non-spontaneous. So So let's look at the next problem. The next problem says to calculate the cell potential to predict whether copper will be oxidized by silver under standard state conditions. So for this problem, you're asked whether copper will be oxidized. So your first thing you can think about is that oxidation means the loss of electrons. So what this reaction will look like is a copper solid going to copper 2 plus in aqueous form, and 2 electrons will be part of the products. So just like the case up in the first problem where you had to flip around the equation to actually get a standard reduction potential and take that number to get the cell potential for the oxidation half reaction, you look up the value in a table for the reduction of copper, the opposite of the one you want, and the value you get for that, for the standard reduction potential in a table, would be 0.034. And in order to get the value for the oxidation of copper solid, or the opposite of this one, you take the negative of 0.34, which is a negative 0.34. So there's the value for your oxidation. And then if copper is being oxidized, that means silver must be reduced. So you gain electrons when you have a reduction. So that means the silver aqueous cation is going to gain an electron to give you the silver solid. So if you look up the potential for that reduction reaction in a table of standard reduction potentials, you find exactly that reaction, and you find that you have a standard reduction potential of 0.80 volts. So you add the cell potential for the oxidation to the cell potential for the reduction reaction. When you add them together, you get 0.46 volts. And that is actually the cell potential value that you want to calculate to help you answer this question of whether or not this reaction will occur. Will copper be oxidized by silver? And in this case, the answer is yes, because the standard or the cell potential is positive. And when the cell potential is positive, that means the reaction is spontaneous. So the answer to this question is that yes, the silver cation in aqueous form will oxidize the copper solid. And that's it. We've done both of the problems, so we're finished.